our world and beyond. Space, in partnership with the European Space Agency.
We constantly track our weather as it becomes warmer or cooler, wetter or drier. But what about the long term, the weather over decades and centuries? At what point does weather become climate?
We cannot say that a particular season or a particular month, if it was unusual, was definitely down to climate change. It's not possible because there is chaos in the atmosphere.
We make sense of that chaos by looking for trends. And these days we have a perfect vantage point from space.
The satellites, they play the key role on providing the global picture. So they provide the satellite data on a very large scale.
But when weather becomes climate, history plays a vital role too.
This is a treasure.
To find out when weather becomes climate, how one is reflected in another, we begin our journey at Eumetsat in Germany. The world of weather watching is ruled by an armada of satellites, and Eumetsat are their masters. The organisation owns and runs Europe's fleet of high-precision machines, and that means it manages two classes of satellite with very different orbits.
The first orbit is the geostationary orbit, located at 36,000 kilometers, which is about this distance from the Earth. You look always on the same location of the Earth. You can have very high refresh rate, and you can have kind of real-time data because you are always in visibility from the ground station. But the visibility on the pole is missing. So for that, another type of satellite has been developed. These are the polar satellites. When they are flying from pole to pole, the Earth is also turning around. So at the end of the day, you have possibility to view the complete Earth.
The European Space Agency develops the satellites for Eumetsat. They've become hugely powerful devices. The Metop polar orbiting satellites offer high-resolution temperature and humidity measurements, while the geostationary Meteosat satellites offer a dozen different images of Earth in near real time.
So these 12 images are in 12 different wavelengths. And each of these wavelengths are telling you something about the Earth, its temperature and its atmosphere. Whether it is cloud coverage, whether it is land temperature or atmosphere temperature. And also, of course, one important aspect of meteorology is about humidity.
The satellite age means we now know more about our weather than ever before. But what about climate? How is that long-term concept defined and understood in modern science?
So when you average all your weather parameters, your geophysical quantities, temperature, humidity, over 30 years, that we call the reference climate. Satellites, as they exist, do not cover a lot of the climate period over the last couple of hundred years. It's only, say, credible data exists for much of the atmosphere for temperature records as of 1979.
The satellite data for the past 30 years is already a huge asset for climate scientists at the UK's Met Office. While the weather forecasters here take Eumetsat satellite data and predict what the atmosphere will do in the next few hours, the climate scientists look back a few months or a few years and analyse what happened.
Historical data have really two key uses, I would say. The first is that by looking back at historical climate data, we can understand the ups and downs and the variability, and we can use that to test our computer models to to see whether or not they can reproduce the same ups and downs, and whether or not they're coded up properly, whether they contain the right science and the right physics. The second use of the historical data are to test our forecasts. So we start from before the winter with only what we would have known and do an honest test of whether we could predict the coming winter. And we do that for every year, and then we look at whether the outcomes match what happened in the historical data.
If you look in the right place, then you can find accurate weather data reaching far back in time. And that's useful for spotting even longer-term trends and natural variability in the climate. One of those places is the British Library, the guardian of a rich history of weather-watching data that's now being mined by climate scientist Philip Brohan. He spent many hours scrutinising old documents.
So you can obviously see this. What we're really interested in doing is trying to find out how the weather has varied over the long term. So we know an awful lot about present-day weather from all the satellite data and all the other data that comes streaming into the Met Office. But if we have a big storm or something like that, people are going to sit there and say, well, is this just the sort of weather that turns up from time to time? Is this a change in the world? Is this some sort of climate change? So it's really useful to be able to compare weather, particularly exciting weather like storms or droughts, flooding, with historical records.
Some of those historical records began their lives at sea. These are logbooks from the British East India Company sailing ships which traded with India and China in the 18th and 19th centuries.
This is the logbook for the ship, the Sherborne, which was one of the East India Company's ships. And the logbook is for 1833, and it's about to head out from London towards Calcutta. Page is for the 28th of October 1833. So at the top it says, for instance, moderate breezes and hazy weather. And then again we've got fresh breezes and squally with a heavy southwest swell carried away the masthead.
The British Library has around 9,000 East India Company logbooks dating from as far back as 1605. Other museums hold thousands more, including those from famous tea clipper, the Cutty Sark. For the East India Company, the data becomes genuinely useful for historical climatology from 1789, because that was when the officers started keeping objective and accurate weather records.
The officer of the watch would have kept careful observations of the weather throughout the day in case they needed to reset the sails. They needed to keep that information to keep track of the position of the ship and for navigation. But at noon every day, they'd have made a little bit of an extra special effort. So at noon every day, they observed the height of the sun, they worked out very carefully the ship's position, and they'd also, in these particular cases, have gone down probably to the captain's cabin, to the galley at the back of the ship, where they kept new and expensive instruments, a barometer and a thermometer, and they'd have recorded the height of the mercury in both instruments, which would have told them the air pressure and the temperature, which they could use to understand the short-term changes in the weather.
The historic records are a rich resource with direct data taken on the spot at a given time and place. But is it compatible with the satellite age?
Satellites measure in a very different way. We measure at the top of the atmosphere radiation fields, and these radiation fields contain information about the geophysical quantity that we are actually interested in, like temperature profiles, humidity profiles, ozone content of the atmosphere, or another example, wind speed at the ocean surface. So the measurement principle is quite different. Satellites measure something, and the geophysical quantity that we are interested in gets inferred.
The way they're measured is quite different, but what ties the historic data and the satellite data together is that the fundamental rules of physics that govern our climate system haven't changed. That means both sources of weather information can help scientists refine their climate models. And they can both help us analyse the subtle question of when changeable weather becomes a changing climate.
In order to characterize when changes are really happening, we have to bear in mind that we expect some variability. But of course, if there is, say, an upward trend or a downward trend in something, then it's looking at the statistics of when that trend sticks out from the noise and the variability that you've seen historically. When does it poke out from that and look unusual?
Individual event is not really a proof of a change. A proof of the change is a long-term, statistically significant change. So one event, one occasion, doesn't really provide that statistical significance. Many of these events give a hint, and eventually, if you have too many, for instance, all the summers get hotter, then you have a statistically, mathematically proven record that the climate is changing.
Fundamentally, we're establishing the same information. We're trying to understand the state of the atmosphere. The information we get from the cutting arc is much more limited than the information we get today from our wide collection of satellite, surface and other observations, but we can still use it in very much the same way. I doubt very much that they expected that in the 21st century people would still be interested in their results and still be using them, but that's exactly what happened. Those records are still very valuable today.
Combining the simple records of old ships with the high-precision, high-density data flows from fleets of satellites allows us to trace the line between weather and climate, identify natural variability in our weather, and define how greenhouse gases are changing our atmosphere.